All right, welcome back to Chapter 10, System Architecture. You may be familiar with modern architecture for networks. You have a personal computer that connects wirelessly or wired to a network, sharing files. Sometimes it might even be on the cloud. But if you look back originally, a lot of large networks were really just mainframes, where you had a large, physically large computer that would take up an entire room, sometimes two, and that was accessed through many terminals. Sometimes these would be called dumb terminals because it was nothing more than a display and a keyboard. It did all of its work on the server and you would access it. Sometimes there were time frames where certain terminals would be available. If more people were on it, then obviously your processing power would be cut in half or even more. As technology grew, mostly as personal computers became more and more powerful, we got to move away from having a mainframe. We had systems that were, one, small enough and affordable enough, and powerful enough that they could run programs independently of a mainframe. When we would connect multiple computers together, then we would get a network. We can either have a local area network, something you might have in an office or a LAN, and this is where you can share data across multiple systems. You would still have a server, and that would be the central repository of all of this information, but many computers could access that. The computers can talk to each other. We can scale this up a little bit and go to a WAN, a wide area network, and it's just multiple LANs that are connected. A lot of times businesses will use these so that way they can have different offices all connected to one large WAN. So if you started at the office, you had your LAN, your local area network, and that was for all the computers and servers, printers, and everything in that office. But that office could connect to a WAN, a wide area network, and it can communicate with other offices. I do want to make a point. There's sometimes confusion with WAN. People will incorrectly call it a wireless access network, thinking of Wi-Fi. That's not WAN. When we talk about Wi-Fi, that's really WAP, wireless access point. A lot of people get that confused with WAN. I want to make sure that you understand there is a difference between a WAN and a WAP. It's really hard to find a program that has no internet access capability at all. Pretty much every application we use either runs solely with an internet connection or is heavily dependent on an internet connection. And that wasn't always the case. We're seeing now more of a resurgence to cloud computing. And I call it a resurgence because I see this really as a full circle. Like we talked before when we had mainframes, a lot of your information and processing power was in one location. Now with cloud computing, we're seeing a lot of our information being stored in one location, although we still have great processing powers at our local machines. A lot of times larger applications would be the bulk of that processing would be done on the server, on the cloud elsewhere. So I kind of see this as a 360 back to what we had in the mid to late 70s with a mainframe. But cloud computing is really just using infrastructure that is elsewhere, and we're accessing it through the internet. This makes compatibility so much easier because you can have Macs, Windows, and Linux machines all accessing the same files and the same resources with very little compatibility issues, and it allows organizations to have less expensive, less powerful machines that their users can use. I think a lot of high schools are handing out Chromebooks to the students because a lot of the applications they're using are on the cloud. They are Google Docs, Google Sheets, Google Drive. You don't need a very powerful, robust machine to access that. So it's a big cost savings. And of course, this leads to Web 2.0, or the second generation of the web, where there is more collaboration and users can interact directly and share really dynamic content. Wikis are can only happen in Web 2.0. You wouldn't have seen this in the late 80s and early 90s, because any sort of wikis, whether it's a Wikipedia, which is the most well-known, or any sub-wiki, you might have certain fan clubs or certain groups that have a Wikipedia, or correction, a wiki page covering that topic. These are all created by users just like you and I. It's not one organization putting this out. There's pros and cons for this. We're using collective knowledge to create and share information. But because anybody can create and share information, it is susceptible to tampering. If you look in the early days of Wikipedia, there was a user who went by the name of Willie on Wheels, and he had a picture of an old-time car. And he would go and deliberately mess up articles. It was malicious, and a lot of it would be just replacing the article with a picture of this old-time car. That's kind of how he went on with Willie on Wheels. But this was eye-opening to the community, because at that time, a lot of Wikipedia users really had good intentions to build an open and free community to share information, but we saw how weak it could be and how susceptible it was to bad actors. Since then, Wikipedia and a lot of other wikis have better review standards, and it's not as easy for one person to go and put incorrect information up anymore. But that's the downside when you get into public group collaboration. So how can businesses take advantage of this? Well, we can have e-commerce architectures. We can have a online store that our consumers can come and purchase and interact with us. Like anything else, we could build this in-house, we can outsource it, or we can do a hybrid approach. Like anything, when we build it in-house, we have total control over this. We can make this look and feel exactly how we want it to. We can scale it to our needs. If we have a certain way we do our shipping and handling, we can make sure that this solution fits that. It may be more costly. It may be difficult to maintain if we don't have knowledgeable staff to really run and maintain this system, but we're going to get a really good, unique, it's going to help our brand because it's going to stick out. When you do a package solution where we go to a provider and buy it, well, you get familiar feels, right? Other websites are using this package, so it might look similar. Obviously, you have logos differently, you can move things around, but it's gonna be a package solution. And you can even buy through a service provider, application service provider, where you're being charged a fee and they can scale it up. But again, these are not in-house systems. They're not fully catered to us. We're buying the vast majority from somebody else with that look and feel, and we make minor tweaks. Let's talk a little bit about network models. This thought process was really developed in the late 70s with the OSI model, the Open System Interconnection model. And basically this says that, when we're talking about networking, there are a series of protocol layers, and each layer has a very specific set of functions. So if you look up the OSI model, you'll see different blocks with each layer: application layer, transport layer, network layer, and how they interact with each other. And that's kind of the base of every network. And then we can break that down into physical and logical views. Physical is, well, how it's actually laid out, how the cabling goes and what goes into this switch and this hub. And the logical just describes how the components interact. And there's different types of networks. Some of these are a little more archaic, but we still see these. We have ring networks, star networks, and mesh networks. We're going to get a little more and look at some diagrams for each of these. When we talk about hierarchical network, this is probably what we're most familiar with in business. We have the whole network is broken down into different departments. So we would have the HR server, the finance server, the operations server, and all of the users in that department connect directly to that server. And then each of those servers then go to a higher server. So that's where you have this hierarchy. A lot of businesses use this because it's really easy to track users. It's easy to compartmentalize data. And it just makes updating a little easier too, because you can spread it out. Well, hey, Monday we're going to push all the updates to finance. Wednesday we're going to push everything over to HR. So that way, if there is some sort of catastrophic issue with an update, you're not taking out the whole company, you're just taking out a department, which in itself is bad, but it's not as bad. We have bus and ring networks. We'll talk about ring networks a little bit. These are a little more archaic. These were real popular in the late 80s and 90s. Data flows in one direction, and I think you can figure out there's a weak point. If something happened to that printer or one of those computers, well, the flow just stops, right? But it's a very simple network. It's cheaper. A bus network is kind of the same. You have a main bus that's kind of the trunk, and then everything connects off of that, and there's a single communication path. Star networks, we have one switch that reaches out to each terminals. This is also very popular, especially with home networks and smaller businesses where you don't need, there's not a lot of robustness. We don't need to break things down into departments. And finally, probably one of my favorite and one of the things I have the most interaction with, especially when I was in the Navy, mesh networks. A lot of military, active duty contractors, DoD, use mesh networks because of how reliable and how robust they are. You see, there's a connection to everything. Every terminal goes to the servers, printers. Redundancy is built into this, but it's incredibly expensive. You can, quadruple the cost of a network with a mesh network. But when you're dealing with, government networks or maybe scientific research where you need that reliability, that cost can be justified. Finally, we're going to talk about wireless local area networks. I'm sure you've heard of IEEE 802.11 and then some number, A, B, G, N, max, whatever. But the idea is this is a standard, and it's all governed by the Institute of Electrical and Electronics Engineers, IEEE. They come up with standards for wireless interconnection to make sure that everything is compatible, because it doesn't make sense if you had, I have a Dell wireless router, so your Lenovo or your Apple can't connect to it. They want to make sure that this protocol is universal, that anything can access to it, and that to some degree there is backwards compatibility between A, B, G, and N. Terms and conditions apply, obviously, but for the most part, most devices will be able to connect to most networks. Security layers add complications into this, but at least on paper, any 802.11 device should be able to connect to other 802.11 devices. Security is up to the OS more often than not, and sometimes it just can't deal with the encryption. So Wi-Fi, we see a lot of this for internet connections. You use Wi-Fi at your house. You're probably on Wi-Fi right now. It's at campuses, it's in bus stations, train stations, everywhere. That is how the vast majority of our devices connect to the internet. Another wireless standard you're going to run into is Bluetooth, and this is really just for short distance communication. Maybe you want to upload from your phone to your laptop, listen to music through headphones. Certain wireless devices, keyboards, and mice are Bluetooth. So these are all things we need to know, things we need to understand, basics of their operations. So that's going to wrap up this chapter. Keep pushing forward. As always, if you have any questions, please let me know.